Hello everyone. Today we will discuss about the functioning of internal combustion engine. So you can see this is a vertical internal combustion engine, and in this case you can see this is a cylinder, okay, and this is a piston, this is a connecting rod here to here, and this is a crank, and this is crankshaft, and this is crank pin. So this crank is connected with this connecting rod using this crank pin. So actually this piston is moving TDC to BDC or BDC to TDC, and its motion is called reciprocating motion. And this is suppose it is SI engine, spark ignition engine or petrol engine, then we will provide a spark plug in this location, and if it is diesel engine, in this case it will be injector. Okay, so this is actually inlet valve and this is outlet valve. So here you can see this piston is moving TDC to BDC. TDC is top dead center and BDC is bottom dead center. So this piston cannot go beyond this point in upward direction. So this is called top dead center. So this is its dead position at this point in upward direction, and this is the dead position of this piston in the downward direction. So below this point, this piston cannot move. So this is bottom dead center. So this piston actually moving TDC to BDC, BDC to TDC, and this length is called stroke length. Okay, and the volume covered by this piston during this movement TDC to BDC is called swept volume, and the volume in the above location of this piston is called clearance volume. So this is actually clearance volume VC, and here to here it is VS, means swept volume VS. Okay, and this length is stroke length L. So now we can say this is horizontal alignment of this IC engine. So you can see in this case only is difference of IDC and ODC, and here we have used TDC and BDC. So actually this piston is moving from IDC to ODC, ODC to IDC. So IDC is inner dead center and ODC is outer dead center. So this distance IDC to ODC is called stroke length L. Okay, so functioning is same, only is the difference of alignment. So this is vertical alignment of this engine, and this is horizontal alignment of this engine. So we will use TDC and BDC in case of vertical alignment, and we will use IDC and ODC in case of horizontal alignment of this internal combustion engine. So this engine may be petrol engine or maybe diesel engine. So we will discuss about diesel engine first. So here you can see this piston, suppose this piston is at IDC position, okay, and this is clearance volume VC, okay, and this is the swept volume VS, and this length is L, stroke length. So here when this piston will move IDC to ODC, IDC to ODC, in this situation this exhaust valve will be closed and the inlet valve will be open. So the air will be sucked by this piston, because this piston is moving IDC to ODC, left to right. So air will be sucked by this piston in case of diesel engine or CI engine, compressed ignition engine. So here this piston is moving IDC to TDC, and it is sucking air in this combustion chamber. So actually this will be combustion chamber. So this piston is moving IDC to TDC, and inlet valve is open. So actually when this inlet valve was open, the pressure was atmospheric in this control volume. When this piston will move rapidly, so the volume, so the air will be sucked and the pressure inside this cylinder will be decreased. So this pressure is atmospheric at this 0 point, and this is decreasing when is piston moving IDC to ODC, and then it will be atmospheric again at ODC condition, because the piston is moving rapidly and it is sucking air, so some vacuum will be created inside this combustion chamber. So this is the suction stroke. Okay, now this piston will move ODC to IDC again. So I will show you this process in the next figure. So this was our step 1. Okay, so in step 1 I have discussed about the suction stroke. Now in the second step I will discuss about the compression process. So actually this piston is moving ODC to IDC, because in the previous stroke air was sucked in this combustion chamber. Okay, and in the compression stroke this exhaust valve and this inlet valve, both valves are closed, and this piston is moving ODC to IDC. So the air enclosed in this cylinder will be compressed. Okay, so here you can see volume is decreasing. This volume is decreasing when this piston is moving ODC to IDC. Okay, so volume is decreasing. Due to decrease of volume, pressure will be increased. So here you can see pressure is increasing in vertical upward direction and the volume is increasing left to right. So this is 0 point. Okay, so in x direction volume is decreasing, in y direction pressure is decreasing, but in this process the volume is decreasing ODC to IDC, hence the pressure is increased. So due to compression and higher pressure, the temperature of air will be high. Okay, so this is actually compression stroke. So this compression stroke is taking place at constant entropy, and this is called adiabatic compression stroke or process. Okay, so this pressure and volume variation of this piston is presented in this graph. So this is process 1 to 2. So when this piston will move ODC to IDC, the volume will be decreased continuously and the pressure will be increased from ODC to IDC. So this is our step 2. Step 2 means compression stroke. Okay, now we will talk about third process, heat addition. So this is step 3, heat addition process or stroke. Okay, so actually this piston was at IDC position when the compression stroke was completed. So now this outlet valve and inlet valve, both valves are closed and the air is already compressed in this combustion chamber, and now we are injecting this fuel by using injector. So the fuel injected in this combustion chamber will occupy some volume. So in pink color you can see this is diesel. So actually we are injecting fuel continuously, and this piston is moving continuously from this position to this position. So actually fuel is injected and piston is moving. So actually volume is not constant because piston is moving, but pressure is constant. So when we will spray or inject the diesel, so this diesel will occupy this volume, and this occupancy of volume will be at constant pressure. So here to here it will be the heat addition at constant pressure. So this is the heat addition at constant pressure. So this is process 2 to 3. So this point is 2 and this point is 3. Okay, so this is the heat addition at constant pressure. So P will be constant here. Okay, now we will talk about the step 4. So this is step 4, and this is the adiabatic 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 expansion, or it is also called power stroke. Okay, so during this process entropy will be constant. Okay, so actually this piston is moving this location to this location, because at the end of compression piston was on this location and air was compressed here. Then we added the diesel, so the piston moved here to here. Okay, now due to the combustion of air and fuel, so actually the air was very hot, means temperature of air was very high due to higher pressure. So when we injected the diesel, so self ignition was started due to high temperature. So due to the combustion of fuel, the piston is pushed IDC to ODC. So piston is moving here to here to here. So this is actually power stroke. Okay, so after the combustion of fuel, the gases will push this piston, so this will be expansion of the gases. So here to here it was fuel injection at constant pressure, and here to here it is expansion. So this process is also called power stroke. Okay, so this is the power stroke from point 3 to 4. So this process is taking place at constant entropy, and this is called expansion work or power stroke. So this piston is moving left to right, and in this situation the volume is increasing and pressure is decreasing. Okay, so this is power stroke or expansion stroke. Now we will talk about stage 5th or process 5th. So now we can say this is step 5. Okay, so here you can see when the piston was moving IDC to TDC, expansion was taking place. Okay, so at the end of the expansion stroke, this piston will be on ODC condition, and this valve, exhaust valve, will be open. So the hot gases will be thrown out through this outlet. So this actually heat rejection process. So piston was at this ODC condition, and this outlet valve was opened, and high pressure gases was released from this cylinder into the surroundings. So this piston is at ODC, means volume is constant because piston is not moving, and this is open. So in this situation, the heat rejected from this IC engine is at constant volume. So this is actually heat rejection process at constant volume. Okay, now we will talk about last step, 6th. So this is step 6th, and it is called exhaust stroke. Okay, so actually the piston was at ODC here, and this outlet valve opened in the previous stroke, means heat rejection process. You can see here. Okay, you can see here in this figure, this one. Now this piston will move ODC to IDC, and exhaust valve is already open. So the burnt gases from this cylinder will be thrown out into the surroundings via this outlet valve. So actually when the piston was moving ODC, the pressure was atmospheric because this valve was opened, and when this was traveling rapidly ODC to IDC, so a small increase of pressure was noticed. So this is actually exhaust stroke, and at the end of this exhaust stroke the pressure will be atmospheric again at IDC position of this piston. So this was the functioning of this internal combustion engine. So this is having 6 strokes. First is suction stroke. Suction stroke, when the piston is moving IDC to ODC, so air is sucked. Next is compression stroke. The inlet and the outlet both valves are closed and air is enclosed in this cylinder, and this piston is moving ODC to IDC, means the volume is decreasing. Due to decrease of volume, pressure will be increased, and due to increase in pressure, temperature will also be increased. So this is actually compression stroke or compression process 1 to 2, and this is the heat addition 2 to 3. So diesel was injected and it is occupying some volume. So this is 2 to 3. So this volume 2 to 3 is occupied by this diesel. So this is heat addition at constant pressure. And this is expansion because fuel is burning. So combustion taking place in this combustion chamber, and due to the combustion of fuel, high pressure intensity will push this piston IDC to ODC. So this was power stroke or expansion stroke. So we can say 3 to 4 is reversible adiabatic expansion stroke or power strokes in this PV diagram. And this is the heat rejection. So at this end point of piston, exhaust valve is open. So hot gases are going out through this outlet, and piston is at the ODC. So volume is constant. So this is constant heat rejection at constant volume. Next is the exhaust stroke. So in this stroke, outlet valve is open, but piston is moving ODC to IDC. That's why this will move 1 to 2, and pressure will be atmospheric at point 1 and at point 0. But in the mid, it will be quite higher than the atmospheric pressure. So now we will combine these different processes. This is compression. So you can see this is compression. Okay. So this is actually compression process. This is point 1. Okay. So 1 to 2 is compression, and 2 to 3 is heat addition. So 1 to 2 is compression. You can see here. This is compression, and 2 to 3 is heat addition at constant pressure. So you can see this is the heat addition at constant pressure. Now it is expansion of burnt gases. So this is power stroke or expansion stroke. So this is 3 to 4. So this will be expansion stroke, reversible adiabatic process 3 to 4, and then heat rejection at constant volume. So you can see in this process, heat is rejected at constant volume 4 to 1. Okay, so this is actually heat rejection 4 to 1 at constant volume. So you can see in case of diesel engine, heat addition is taking place at constant pressure 2 to 3 because fuel was added during this process. Okay, so this is actually diesel engine okay. Also it is called CI, compressed ignition engine, and this cycle was given by Rudolf Diesel. Okay, and this is SI engine. SI or petrol engine, petrol or gasoline engine, and this works on the Otto cycle. Okay, so in case of diesel engine, heat addition is taking place at constant pressure, and in this case heat addition is taking place at constant volume. Okay, and the remaining processes are same, so only difference is the heat addition at constant pressure in case of diesel engine, and heat addition at constant volume in case of petrol engine. Because in case of diesel engine we compress only air in the combustion chamber, and due to high pressure, temperature is also very high, then we inject the diesel, which will be ignited in this combustion chamber. But in case of petrol engine, we have to compress air fuel mixture during the compression process. So we provide the mixture of air and fuel from the carburetor, which is compressed during the compression stroke 1 to 2. Okay, then at the top dead center position or IDC position, we provide the sparking from the spark plug. So this air and fuel mixture, compressed air fuel mixture start burning, so combustion is taking place. So this is called heat addition at constant volume, and then the expansion is taking place at constant entropy. This is called power stroke. Again 4 to 1 is heat rejection process at constant volume. So in this situation the piston will be at ODC or top dead center. So this is heat rejection at constant volume and heat addition at constant volume in case of petrol engine, and in case of diesel engine, heat addition will be at constant pressure and heat rejection will be at constant volume. So this was the basic difference between SI and CI engine. So now we will talk about the TS diagram for petrol and diesel engine. So actually this is a TS diagram for diesel engine, and this is for petrol engine. So you can see this is process 1 to 2, compression stroke 1 to 2. So this is adiabatic compression, and 2 to 3 is heat addition at constant pressure, and this is 3 to 4 heat rejection, expansion or power stroke 3 to 4 at constant entropy, and again 4 to 1 is heat rejection at constant volume. So this is diesel cycle, and this is for Otto cycle. In case of Otto cycle, this is adiabatic compression. This is 2 to 3 reversible heat addition at constant volume, and this is 3 to 4 expansion or power stroke, and 4 to 1 is heat rejection at constant volume. So you can see heat addition at constant pressure in the diesel cycle and heat addition at constant volume in Otto cycle. The remaining part is same. So this is the TS diagram for diesel cycle, and this is the TS diagram for Otto cycle. Thanks for watching this video. All the best.